In this video, we see when and how to apply the L'Hopital's rule. In this first limit, we first see if the L'Hopital's applies. This limit is of an infinity over infinity indeterminate form, and the L'Hopital's applies. We apply the L'Hopital's rule and obtain a limit which we can then resolve. The limit is minus 2/3. We can then verify this graphically by comparing our limit with the function. In this limit, we again first see if the L'Hopital's applies, and this is of an infinity times 0 indeterminate form. To apply the L'Hopital's rule, we rewrite this function as a quotient, and now we can apply the L'Hopital's rule. After applying the L'Hopital's rule, it's still indeterminate, so we can apply again. And this gives us a limit that we can resolve. The limit is 0. And again, we can verify this graphically. Again, we compare the limit 0 as x goes to infinity of our function. Again, we first check to see if the L'Hopital's rule applies. And this function, or this limit, has a 0 over 0 indeterminate form, so L'Hopital's applies. When we apply L'Hopital's rule, we obtain a limit we can resolve. The limit is minus 35/3, which we can verify graphically. Again, as x approaches 0, we see the function approaches minus 35/3. In this limit, we see if the L'Hopital's still applies, as we're going to infinity, and this limit is of an undefined over infinity form, and the L'Hopital's does not apply. But since the numerator is bounded and the denominator goes to infinity, we can apply the squeeze theorem. Since the bounding functions both go to 0, the original limit also goes to 0 as x goes to infinity. And we can verify this graphically again, graphing the limit, the bounding functions, and our function. We again first check to see if the L'Hopital's rule applies. And evaluating at 0 gives us 9 over minus 7, so we're done. We do not need to use the L'Hopital's rule, we simply need to evaluate the limit. And again, we can verify this graphically. In this final limit, we again check to see if L'Hopital's rules applies. And this limit has a 0 over 0 indeterminate form. So L'Hopital's applies. So we apply L'Hopital's rule. And this is a limit that we can resolve. The limit is 2/3. And we can verify this graphically.